That unit was a little bit of a struggle for some of us. Some of us felt really comfortable with it. The nice thing is that we are starting a new unit, and this new unit is very heavily rooted in geometry, not data and statistics. Therefore, even if you didn't love the last unit, you are starting over fresh. You don't have to have been super successful in the last unit to be successful on this one. So take advantage of this time. On Monday, we will switch groups up. We'll use the random team generator because we're starting a new unit. But let's take advantage of this new unit to start over fresh. Even if you were sitting there struggling, if you were getting lethargic and not paying attention because you were struggling with the content, this is a chance for you to start over fresh. Yes, so let's knock this out. We are doing lesson 1, the squariest square. And this getting started is going to be fundamental to everything we do this year, but it's not terribly difficult to get started on it. I do want you to pay attention with this book, right? I was part of the curriculum committee who actually selected this book to be used here at Hillcrest and throughout the county because we all agreed that this was the best book for students to be able to have a consumable textbook. Every page in here can be ripped out and put into a notebook if you don't want to carry the whole book around with you. I definitely wouldn't carry both volumes around with me every single day, but also this book does an excellent job of identifying learning goals for every single lesson. Those learning goals are what you want to pay attention to because they're what I'm going to be expecting out of you when it comes to assessments. And it identifies key terms. These key terms are things that are going to be defined throughout the lesson, and you really need to pay attention to them. Because we talked about this before, at its core, mathematics is what? Study of patterns and relationships. And so we have to build our what to describe those patterns and relationships. It starts with an L. Our language. Was that Addison who said that?
No.
Right? The language is patterns and relationships. And so to describe and talk about those things, we need to develop our language. Now, one thing I do want to quickly point out, and I need to point this out to my Algebra 2 students, mark this page with your hand, but I do want you to flip to the very back of the book. So mark that page with your hand so you don't lose that page, but flip to the very back of the book, the last 20 pages or so.
Oh, I would.
Okay? Okay, not like the absolute last page. A little bit before that.
Before?
Yep. What do y'all see there?
Some shapes.
But you'll see very different things. You see examples, but does anyone know what this is called? So before the index, we can see a glossary here. This is probably one of your best resources as a math student before the index. Right? This glossary here doesn't just define things, it gives examples, and it gives very mathematically accurate examples. So be aware of these details, okay? So, hey, focus. I'll like hold those assessments. That's fine. I won't. Alright. Hey, focus and attention, please. So, on top of these learning goals right here, I consolidated those 3 into 2 shorter ones. I want you to be able to differentiate informal and formal geometric reasoning, and I want you to be able to recall key features of some geometric figures. Are there any words from those learning goals that I need to clarify or explain? None of those words? Differentiate and geometric. Okay, so ask those questions. So differentiate. Anybody know or have an idea what that might tie into, Joey?
Different.
Okay. And not just being different, but see how it says informal and formal?
They're 2 different groups.
They're 2 different groups, so it's to tell the difference between those 2 groups. That's what I mean by differentiate, be able to tell the difference between those 2 groups. And we need to talk probably about geometric reasoning and geometric figures, although I will say, what should you think about when you see geometric?
Geometry.
Geometry. That's all we're talking about. Geometry ideas. But geometric is an adjective. Informal and formal, right? So we can talk all day using normal language, I would say, but we want to develop our proper mathematical and geometric reasoning, right? So it's learning how to just talk generally about things to getting to a point where we're properly talking about them. Okay, so that's what we're looking at here. By the way, Joey, it's M1-7 in the textbook. And same thing, Wesley. Keandre, did you never get a book?
We finna get you one.
Huh?
We finna get you one. I ain't know he had one.
Say that one more time.
We finna get Joel a book. We ain't know if he had one.
Joey, do you have a book? Yes, one with you. Is that volume 1 though? Give it to Keandre, he needs it.
Get two.
Okay, then why would you give him volume 2?
I ain't know they didn't look on the back.
But hey, Keandre, I'm pretty sure there's still some shrink wrapped ones back there, which means there's a volume 1. Hey guys, really quickly, if you took a volume 1, take both volume 1 and volume 2 and bring me the package of volume 1 and volume 2 that you have at home.
Oh, I ain't getting one.
Huh?
I ain't never get. I never got no
You had to have. I gave. They were shrink wrapped together, my man.
Yeah, I never got yours.
on the first day.
So you never got a book in
I
general.
wasn't here on the first day.
Okay.
No,
So
I
if you
ain't.
never got books, then that might be the
I
case.
had checked out.
All right. Anyways, let's focus up here though. So this is getting started. Every lesson in the book will have a getting started to it. So we're on M1-8 now. Okay. So again, key terms, glossary in the back. We're now looking at M1-8. This is super straightforward. Try to sketch a perfect square like the one shown without tracing or using tools. You have 60 seconds to get your best perfect square down. So what's it? You don't have. So get a sheet of paper out and write this down.
How are you supposed to copy your own
Easier.
drawing?
That is one point. Marlon is bringing a good point up. You can tear these pages out. Just I would make sure I put it back into the book where it's supposed to go, or in my notebook in order. Okay. So do your best to sketch a perfect square. We've got about 20 seconds. Okay.
Oh, I got it.
All right. So now that was only 10. I'll give you all 5 more. Remember, I'm just asking you to do your best. You don't have to be perfect with it. Number 2, though, explain how you could use, or how you could decide whether one square is closer to perfect than another. Use your criteria to judge your and your classmates' best squares. So 2 things before you get started on that. 1, I'm just going to give you 2 or 3 minutes to talk about this within your small groups, and then we're going to have a whole class discussion. 2, at the end here it says use your criteria to judge yours and your classmates' best squares. If you need, say, a ruler or a protractor, I have those things up here so that you can grab them. Hey, hold on a second. I haven't released y'all yet. Make a decision together about what you need to determine if it's a perfect square or not. Then come get the resources you need. You got 2 to 3 minutes to talk about what could help you determine if it's a perfect square. Write your ideas down. Let's get to work.
Looking at their links.
You didn't want to get one for the whole group?
It's closer to a perfect square. How would you identify it?
Excuse you. Put it back. If you can't use it responsibly, you don't get to handle it at all. You can get one for everybody else. That was ridiculous. Pull up. How much math are you talking about right now? How much math you talking about right now? I didn't ask. Talk about your math. No. Guys, all that you're trying to do is you are trying to figure out who has the best square right now. So talk about how you can determine that and then check. We got, I'll give y'all 6 more seconds at this point.
Oh, I thought we had it next week. I should be right
But have y'all talked about actually how you're going to determine who has the best square? Because I don't see any ideas written down under number 2 yet. And y'all don't have any tools yet to actually just figure it out. What tools do you need? Okay. How long, y'all? Every Saturday.
I said, looking at this, I hadn't expected my answer. She got my cooking on.
Let's do some math, guys. Have y'all actually figured out who has the best square yet? But no, you're not. Like, y'all were talking about y'all have these. Huh?
She was like,
But that's not the question. That's what I'm okay, I need to rephrase this. It doesn't matter what you think. How do you determine if it's the best square or not? Okay, so have you actually measured the sides to see who has the most accurate square? Oh. That's not the question. This is a math class. It's not a money class. I know math is involved in money, but not anything. This is you haven't even drawn the square out. Thank you. Thank you. Thank you. Thank you. So, here's the thing. The answer that y'all came up with for number 2 about, hey, how could you decide whether one square is closer to perfect than another? That would come into this idea of informal geometric reasoning, right? You're coming up with ideas, but it may not be 100% proof yet. So, like, what were some ideas that some of us came up with to put here to check who has the best square? Peyton.
So measuring, you see, like, what's compared to the other one.
When you say measure them, what do you mean?
Like, measuring the squares that you made and compare it to the other one to see which one's the closest.
But how are you measuring? Okay, so how are you going to use the ruler? You're measuring the lengths of the height or the width. Okay, but hold on a second. For it to be a square, do you have to differentiate or tell the difference between the height and the width?
no. Yes. Yeah, because you can be a rectangle if you got to.
Because they're all what? They should all be the same, right?
Yeah, they should be parallel.
We're going to talk about that in a second too. So these are things we want to consider. So we need to work on our language. We need to measure the side lengths. See how more accurate that is? Like when I say measure the side lengths, does everyone know what I'm talking about?
No.
Yes.
Yes.
Right. The sides of the square. So we need to work on that language because when we are properly communicating, it is easier for everybody to access the information. I legitimately didn't quite know what you were talking about on that. Okay? And you may say you do, but does everyone else? Okay. Oh, you said no. Okay, my bad. Alright, so what I want to talk about though is this. And here's the one thing I will say, Peyton, it sounded like you were saying that you had to compare the square you drew to the other square. Do we have to compare the squares that we drew to the other square to see if we drew a perfect square?
No. I mean, you could, but...
You could, but is that the only square that ever exists in all of the world?
No.
So we need something that determines our squares versus, or just determines if our square is a perfect square. So one idea, and I'm going to go ahead and write this, right, is measure sides to compare to the other square. But we all are now agreeing, right? Is that fully necessary?
No.
I mean,
Yes.
does your square have to have the same side lengths as the other square?
No.
No. Okay, so what is necessary to have a square?
4 right.
Parallel.
4 right angles.
Okay, so we need 4 right angles. Hey, what geometric tool would you actually need to determine the angles?
Treasure.
A protractor.
What are the things you got?
Oh, we need a protractor to determine the angle measures. Whoopsies. So, that's one thing we definitely need. We do need a ruler as well. Okay, but what do we need, what else needs to be true to have a square?
Parallel.
For what? Okay, so 4 parallel sides.
Need 4 90-degree angles.
Okay, so remember that's what the right angle is. If you have a right angle, it has 90 degrees. Yep. Okay, so 4 parallel sides is what we're saying.
Yeah.
Okay. What else are y'all thinking? Notice this is all under number 2. Any other things that we would need to know it's a square? Okay. No other ideas? That's it? So here's where, and that's what I want you to understand. Me as a teacher, I need to hear what your ideas are so that I can tell you, hey, we're good on this, but we may need to build this up a little bit because we have some correct ideas, but we have some other ideas that we need to address. First off, I do want to point this out. If you have 4 parallel sides, is that a square? That's 4 sides that are parallel though.
But you need 4
Technically
right
it's not a
angles.
side,
Both sides better than
but all 4 sides can't be parallel. So which sides need to be parallel?
the top, the height, and the length.
How could I describe, so like looking here, right? If I'm looking at this side, which side needs to be parallel to it?
The opposite side.
The opposite side. If you weren't aware of this, this little symbol right here can indicate that things are parallel. So, the opposite sides need to be parallel, right? What's across from it? Similarly, what needs to be parallel to this side?
Bottom.
The bottom. Notice I'm using these little arrows. These single arrows indicate that these 2 sides go together. The doubles indicate that these 2 sides go together. That symbol just means parallel. You may see that in some textbooks, things like that. So what are some properties of squares that you know? All right, so this is where we're going to start getting into formal mathematical reasoning. 1, the opposite sides are what? Are parallel. Okay? And some of us said 4 right angles. Does anyone know why we get right angles though? To Marlon? Say again. Say it louder. Okay, so that's a different idea. So let's go ahead and hit on that for a second. When you say all sides are equal, can anyone add on to or push back on that to make it more mathematically accurate?
Okay.
So he said that all sides are equal.
And even if you use the right angle, it'll still have that little box.
Hold on a second. You're not listening to what Marlon's saying. And I need y'all to focus on this. He said that all sides are equal. What is he talking about? We need to be more mathematically accurate.
Oh, right.
All sides are equivalent.
Not necessarily equivalent. I see what you're saying there, but what is he saying are equal? I need to point this out. Only numbers can be equal. So what number is he referring to?
The 4 sides.
So the 90-degree angles are equal, but is that what you were referring to, Marlon, when you said, are you sure about that? I don't think that was, because you said all sides must be equal, right?
So the length,
Hey.
Oh, say that one more time.
the length,
The lengths all need to be equal. Don't the lengths have a number associated with them?
yeah.
Ah,
Wasn't that the rest of the first one? Oh, I said.
excuse me, I don't know why y'all being so rude and disrespectful to each other. And I don't know why you're trying to break my rulers. Pause, that's from the other day, that's not supposed to be the bell, it is only 3:11. Okay? So the length of all sides
Word.
are the same. School's not out. Alright, number 3. So the length of all sides are, instead of the same, I can say equal. And then y'all have said that the angles are what kind of angles? 90-degree angles, right angles, which means that these consecutive sides, remember the opposites are parallel, right? There's another P word for these consecutive sides. Perpendicular. There we go. The consecutive sides are perpendicular. That's the reason all 4 sides, or all 4 angles are right angles. Make sure you get those notes down. I'm going to say one more thing, and then I will let you pack up. Jaden, you haven't even attempted to write down those notes for number 13. My man, you can huff and puff all day, but like it's hard to study if you don't have those notes down. Listen, pause for 1 second. One thing I do want to finish with here is this. So in order to determine if a square is a square, we need to be able to measure the length of all those sides, right?
Yeah.
We also need to be able to check to see if those angles are
Perpendicular.
well, the sides are perpendicular, the consecutive sides are perpendicular, so the angles are right angles. Legitimately being honest with me and with yourself, please raise your hand if you feel comfortable using a protractor to measure angles. If you feel comfortable using a protractor to measure angles. Okay, so we need to work on this a little bit on Monday. Is that fair? All right. So you can go ahead and pack up at this point. Hey, listen, stop. Actually, sorry. Let me say this. We still have 1 minute. If your name, stop. Excuse me. I am loud enough that you know to stop, and you're choosing not to. If your name is here, take volume 1 and 2 home with you, and bring me back the new ones that you did not use yet. Alright? Bring me the unopened volume 1 and 2.
So what I do? Dude, I think the bell.
Okay, so
Right. I don't know, but everybody does.
Because of him, bro. He's not gonna.
It's your damn fault.
The bell not finna ring.
Oh, but